In this video, I will be teaching you how to draw the structure of some macromolecules. We have, for the macromolecules, we have sugar and saccharide aldopentose, sugar and saccharide ketohexos, polysaccharide, an amino acid, a peptide chain, which is a part of a protein, triglyceride, or in other words, triacylglycerol, steroid, and nucleotide. So first we will start with drawing the aldopentose. So first, we'll have to draw 4 carbons and place, draw as I am drawing right now, draw the lines. I'm not sure how we call these lines that connect one element to another element, but surely there is a categorization for that. There should be a name for that. But for now, I can't really say what it is, so it's up to you to recognize. But one thing that's important right now is to remember how these lines were positioned accordingly, because positioning is very important, very crucial when it comes to drawing the structure. Right now we're having to draw the aldopentose, so just go along. We have oxygen here with the 2 lines. I'm not sure if we call this a double bond. From the previous videos, we acknowledged that this is a single bond, this is a double bond, this is a triple bond. I'm not sure if that kind of school of thought applies to this lesson of drawing the structures of particular macromolecules. So as you continue, one thing for sure is, let's just imagine that this is an equal sign that is slanted. So we have oxygen here, hydrogen there. So yes, we position hydrogen this way and place another hydrogen there. Place HO, and here we place OH. Below, we place CH2OH, which is basically primary alcohol. This is the UPAC name of alcohol. All right, that's everything for aldopentose. Let's move on to ketohexose. So at the first, we have to draw what's at the very top, which is also CH2OH. We draw a line, a really long vertical line. Actually, not too long. Maybe up to here. We place CH2OH again below. We place an extension there. Here we have an arrow. I mean, not exactly an arrow, but an equal sign, if you say in terms of mathematical terms. So we connect it with an oxygen there. We place 3 horizontal lines here. Place hydrogen in these positions. Place HO here. And for these 2 parts, we place OH. So that's it. That's everything for ketohexose. It depends now on your ability to memorize this. You can use any technique that you want that is really helpful for you, what's most helpful for you. But the way I drew it is ever since a while ago, a few minutes ago. You can take heed of that, and yes, you can improvise on how you will memorize the structure. All right, moving on, we have our next macromolecule, polysaccharide. Now you have to be a little more alert with this in the drawing of the polysaccharide. This is going to be a little tricky. According to images in the internet, the polysaccharide structure is a little complicated, but I will make it easy because actually it is easy. What makes it complicated is the vast amounts, the diversity of the elements that are installed in the structure. So without further ado, first we draw a hexagon. Uh-huh. For now, I'll make it big so that you may be able to see exactly the parts of the hexagon for polysaccharide. So first we place three vertical lines as shown here right now. Uh, First we place oxygen here, oxygen there, then OH here. I'm sorry, I think I recently said oxygen. This is not oxygen. This is hydrogen. I'm actually out of my mind right now. But anyways, we continue. OH. One way to memorize this part is we place OH this way. You can see that the pattern looks like a butterfly, right? Similar to how we solve fractions in mathematics, particularly for solving fractions with the multiplication sign, we use butterfly method. So right now, to memorize what we have in the diagram, we have H and OH inscribed this way. So yes, I hope that is a helpful mnemonic in terms of diagram. For here below, we have H at the top, then CHOH, the same alcohol that we have in the previous macromolecule structures. And as we proceed, we place an inverted L shape here, then place O, then place H here, and at the right side of the hexagon, we place an L, then an inverted L, place H, then O, then H. Now, um, we continue, we proceed to placing an oxygen there. And yes, we finished a portion of the polysaccharide structure. Now, what we have to do is to add another hexagon that would perfectly sync in with it's supposed to connect with this part. So right now, uh, we're going to place vertical line here, then two vertical lines there. If you may see the pattern, you might be able to see it uh, there. I'm not sure how to explain this in words, but I think you can see the puzzle going on. And right now, to make it clearer, we place an O here, an oxygen. In the first, at the left part, the first hexagon that we made recently, I mean earlier, we place an oxygen here. At the right side, at the very recent hexagon, we also placed an oxygen. And right now, we placed a vertical line here and vertical lines here. I hope you can see the logic behind this. It looks pretty obvious already. And with that said, uh, we continue with the butterfly technique, but this time it's also inverted. If OH used to be this, OH and H used to be in this position, well, we'll have to um, exchange them a little bit. What used to be this will now be this, and what used to be this will now be this. Now, with that said, we continue to place CH2OH here. In the diagram, in the actual diagram, I'm not sure why they did not place an H below when supposedly there's an H in the previous hexagon. But that's what the diagram expresses. So we won't be placing an H here, nevertheless. Now with that, we basically created the general puzzle, or the general pattern that will um, repeat always. What we have to do now is um, place an L here, so place H, then it's supposed to continue here. Uh, to further explain what I'm trying to say right now, let's make this smaller. There you go. And duplicate. Now, as you can see, there is some connection, as you can see here. Uh, there. You connect chunk by chunk. So imagine that this is a single polysaccharide and it connects with another one via this system, a connection of two hydrogens and one oxygen. So yes, that basically is the structure of polysaccharide. At first, it does look pretty basic. I've shown how a hexagon is drawn and how um, the chunk of a polysaccharide is drawn, and what makes it complicated is how it's being connected with more and more chunks of it. So yes, so I think you can see the difference now. So there's no proper reason to be confused anymore. Let's move on with the drawing of an amino acid. So right now, we have to place N, then C, then another C. Connect these with um, lines in this respect. We place a double line here at the right. In geographical means, we place a slanted equal sign northeast of the amino acid. And we place an oxygen there. Then below we have OH. Then here at the middle below, we have CH sub 3. Then we have H above. Then H at the left, both at the north and at the south. So yes, that's basically how we draw an amino acid. This is it, the final product. Now, for peptide chain, a part of protein, the how we draw the peptide chain is similar to how we have drawn the polysaccharide. It has a basic chunk which makes a structure look complicated because it's duplicated many times. In the structure that's seen in the internet, the chunk is repeated at least 6 times. But of course, it goes on. The quantity goes on. So without further ado, let's continue. Um, so let's place 3 dots there to show that the chain is unending. It's like a line without segments. So first we place CH, then lines that way, place R below, then with the red ball pen, place C, then N, then H, then O. Now, it may look confusing at first, but when we illustrate the lines, it looks less complicated. Then place a dash line there. And yes, this is it. This is one chunk of the peptide chain. What makes it a little more complicated is how we duplicate it. So duplicate another chain like there, just like this. So we have 3 chunks in this chain. In the image, in the actual image, uh, we have six chunks of the peptide chain that are linked together. So we'll just have to make this smaller so that 6 would fit. All right, let's continue duplicating. So 4, 5, and 6. Let's make this smaller again. I'm so sorry. I need a few seconds to reshape this part. All right. Now, this is the easy part of drawing a peptide chain. We just keep on repeating the sequence, the pattern, but nonetheless, at the sixth uh, chunk of the chain, we have to replace N. We're replacing nitrogen with NH. So yes, that's the only distinction that we have to take heed of, to take note of when drawing the peptide chain. Everything follows in suit. We have OCNH, 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 OCNH. But at the very end, I'm not sure if this is really the last chunk, but we acknowledge that this is OCNHH. This is NH, not N. All right, let's move on to triglyceride. Apologies if I'm not able to pronounce it correctly, since um, in the simple mind, in the mind of a simple person, um, it may be a little difficult to mention these scientific words. Anyways, for the structure, triglyceride will compose of this structure. Let's make the distances a little long because the structure is also going to be a little bulky. Yes, you heard it, bulky. So H2C, then HC, then another H2C. In that case, we place a dash line there. Um, make this smaller. Oops, never mind. Undo. Uh, place oxygen and place a zigzag this way. So we'll draw this zigzag 4 times. Well, when I mean 4 times, there are 1, 2, 3, 4 vertexes or 4 points to be more in layman's terms. Huh. So yes, this is the general form for the rest of the figures. We still have a lot going on after this. So yes, that's their basic similarity. But apart from that, um, for this part of the structure, um, we'll have another 4 points. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 points, whatever you call that. What matters is we have 8 points to measure the number or the length of the zigzag that we'll have. Now, for the second structure, it's below. After 4 points, we have this structure. I'm not really sure what this is called, but nevertheless, I'm just showing you how it's illustrated. Uh, we'll take a portion of this. This is not accidental. I measured 3 points and an unfinished zigzag there. And yes, that's what finishes the structure for the middle part. All right. Uh, moving on to the very bottom. After 4 points here, we proceed to no one might notice it yet, but maybe some of you might notice that the shape the shape of this looks like a plateau. So for this part, we'll be making 3 plateaus there, and 3 plateaus later, we place that kind of illustration and place with 9, 12, 15. We place an omega sign there and an alpha sign here. Yes, that's it for triglyceride. For steroid, drawing the structure of steroid, it's really easy. It's probably, in subjective opinion, it's probably the easiest among other structures that we have drawn so far. For steroid, we basically draw 3 hexagons and 1 pentagon in this position. So first we have 1 hexagon here, then another hexagon here, another here. This is no accident. This is how we really draw the steroid. And 1 pentagon here. Make it a little smaller. There you go. Yeah, this is steroid. That's it. We're done. For nucleotide, so first we start with placing P, then double bond or the vertical equal sign here. So we place oxygen north, south, east, west. Continue making lines. Then here we have a slant line leading below. We place a pentagon shape. Connect them this way. And below we have OH, alcohol in other words. And we place another vertical line going up. We have nitrogen, which is connected to a pentagon, which is also connected to nitrogen there. Then double bond here. Then connect this to connect that to a hexagon. There. Let's just stick it that way. Double bonds in that position. We place nitrogen here, nitrogen there. Then, going up, we have to readjust the entire structure. There you go. Above, we have NH sub 2. So yes, that's it. That's everything for nucleotide. This is the structure. So yeah, these are the structures of the macromolecules that were discussed in this video. We have aldopentose, ketohexose, polysaccharide, amino acid, peptide chain, triglyceride, steroid, and nucleotide. I hope this video helps in your chemistry learning, and thank you for watching.